Hey, welcome back. So this is the first of a couple sections on a somewhat notorious topic, which is sorting and sorting algorithms. So when I get to this point in my in-person classes, I think this is a topic that a lot of people have been dreading. Some people look forward to it, but it's something that has taken on a bit of weight in the developer, zeitgeist. It's a heavy topic to people, and it's something that is important. And part of the reason, I think, is that it's sort of like the quintessential computer science topic that every blog post ever about getting your dream job at Google, here are 10 things you must master, or every book about acing the computer science interview, there's always a large section devoted to sorting. And for good reason. It is an important topic, it's a great challenge, and it's something that we do all the time, whether we're writing our own code or using a built-in sort method. It's important, but it also doesn't have to be that scary. So let's start by just talking about what sorting is referring to. When we say a sorting algorithm, it's referring to the process of rearranging items in any collection. So we could take a string and sort the individual characters inside a sentence, for example, but we're going to usually be working with arrays, at least for now. Later, we'll talk about sorting other data structures like linked lists or trees, but for now we're focusing on an array. So let's say we have an array of data. We want to write a function that takes that array in and spits out a reordered array. So that could be sorting numbers from smallest to largest, or the other way around, ascending or descending. It could be sorting names alphabetically. Or if we have movie data, let's say movie objects, each movie has a year, a total revenue, it has a director, a title. We could sort them by release year, or we could sort them by revenue. Or we could take their international and domestic revenue, add those together, and then sort by that. So the point is that it doesn't really matter what we're sorting by, what the comparison is, whether it's alphabetically what comes first or numerically what comes first, that doesn't matter. The algorithms behind it don't really care. We're going to focus on working with arrays for now and just numbers. So imagine that I asked you to write a function called sort, and it just takes in an array, and it should return that array sorted. So if I called it like this, with let's just say some random numbers like that, you would need to write code in here in order to make this work so that it should return, let's see, in this case, what are we looking at? 6, 12, 13, 23, and 45 from in ascending order is what we're going to start with. So it's a simple challenge, right? We can look at this. It doesn't seem that bad, but there's a million ways of doing this, and that's part of the problem. Part of what makes sorting algorithms kind of scary is that I can think of 15 probably named algorithms that exist that actually have a name, that are kind of well known, that do the exact same thing. And there are definitely some better ones overall that we will be learning about. Then there are also some that are very niche, that are terrible most of the time, but they do well in certain situations. So just to give you a really quick preview, this is a video I like to show when I'm teaching sorting. We're not going to look at, I'm going to skip around for like 15 seconds, but it visualizes the different approaches to sorting. So basically, over here we have some unsorted data representing, let's say, numbers. The taller items, the taller rows or columns are a larger number. Let's say this is 100, the tallest one here, and the smallest one is representing the number 1. So they're all in this order, totally random, and we write code to go and order them. So here's one approach called selection sort, and you can see that it builds up the array one item at a time. It sorts it one thing at a time until we're done. Then here's another approach. It's called insertion sort, and it's a little bit different. We've got quick sort, very different. We're working from the start and the end at the same time. We've got one called merge sort, another approach, heap sort, radix sort. We're not going to learn every single one of these. There's 15 in this video. Shell sort, bubble sort. But the point is that these are all different approaches. They all end up with the exact same They end up with the same results, but how they get there is very different. So this video is kind of fun to take a look at. I will warn you, the sound is a little bit obnoxious. I'm not playing it here, but definitely don't play it on high volume if you're going to check this video out. So why do we need to learn this? That's the next question. So there are all these different algorithms, and we're going to learn a bunch of them. But why? The first is that sorting is something that is really, really common in programming. And even if you are using the built-in JavaScript sort or the built-in sort method in Ruby or in Python, for example, it still is important to understand what algorithm it's using behind the scenes, because that will help us understand what it's good at and what it's bad at. And that brings us to the next point, which is there are many ways of sorting things, and each algorithm that we see will have pros and cons. So while some are objectively faster than others, there are certain situations where one algorithm, let's say that the data is almost sorted and there's just a couple pieces that are out of place. Some algorithms that are usually slow will be really fast at that. So if you know, for example, that you're working with data that is pretty uniform and it's almost all sorted, but there's a couple things that are out of place, and you want to make sure that it's being sorted as fast as possible, you might want to implement your own sort rather than having to rely on the built-in one, which isn't going to be as fast in that situation. And just to illustrate my point, this is a really cool website I like to show called Sorting Algorithms Animations, and it shows 7 of the most common sorting algorithms: insertion, selection, bubble, shell, merge, heap, and quicksort. These are all different approaches. And what it's showing here are different data sets. So a totally random set of data versus nearly sorted. So you can see we're almost there, but there's a couple items out of place. Totally reversed data, and then data that has few unique items, so a lot of very similar items. Now what I'm going to show you is, first of all, what this does is it just visualizes what happens, just like the video I showed you in the past, but this compares them all at once. So if I hit play on random, you can see basically how their speeds compare. Whoops, I missed it. There we go. How their speeds compare and their approaches compare. So this is totally random data, and you'll see things like heap, quick, merge, and shell finish much before insertion, selection, and bubble, and poor selection just finished. But then if we look at nearly sorted, you'll see that insertion actually finished. I'm pretty sure it finished first, didn't it? Yep, it's done before anything else. Poor selection, still very slow. And I won't go through all of these, but you can feel free to play around with this. But all that this is showing is that something like insertion, which was slow when our data is totally random, was actually very quick when our data was nearly sorted. I think it was the first one to finish. So they have pros and cons, and it's worth understanding them. And the other reason I didn't put on here that we already hinted at, this is a classic interview topic. It's something that it's a great, it's just a good problem. There's so many approaches. It's really a good critical thinking challenge. I can't believe I'm using that phrase. I sound like my dad. It's a good challenge to do. And it's something that comes up in interviews. So of course, that's a good reason to know something if you're trying to interview. So without further ado, let's talk about what we're covering in this section. Our objectives are, first, we're going to implement bubble sort. So this is one algorithm. We'll learn how it works and implement it. Same thing for selection sort and then insertion sort. So these are what I'm calling the elementary sorting algorithms. They definitely are less commonly used because they're less efficient. But that doesn't mean that you shouldn't learn them, and we'll talk more about why it's important, but I kind of already hinted at it. We saw that at least one of the algorithms performed very well in a certain, very specific situation. So we'll be able to analyze these as we go through and figure out when they perform well. And then after this, we will move on to more advanced sorting algorithms as well. So let's start. First, before we even get to bubble, we're going to talk about the built-in JavaScript sort, the sort method, and just learn how that works.